Okay, we are in control flow, the most interesting part of any programming language. Well, assume that you have two numbers. You have taken two numbers from the user, A. You have taken that number from the user using input. I have not supplied the input message here. The message is optional. It's a description. If you supply that, that's okay. If you don't supply even that, that's okay. So A is some number the user will supply when the code will run. B is some number the user will supply when the code will run. Now, once you have A and B in front of you, obviously the user will supply that on the fly. You don't know what the value of A and B are, because when the program will run, only at that time the A will be populated and B will be populated. Your task is whatever the value of A is that you don't know, whatever the value of B is that you don't know. The user will supply those values. Your task is to print the value that is bigger than both. So for example, if A is bigger than B, then print A. If B is bigger than A, then print B. So whatever the bigger value is, print that value. Let's say that's your task. How can you do that? So the question is how? Does Python allow us to do that? For example, if A is bigger, then we should print A. If B is bigger, then we should print B. Remember, again and again, we are talking in terms of if A is bigger. So this is what, if A is larger than B, then this condition will be true. This is like the comparison. So this is true. But then we must have an if condition as well. If A is bigger, then do what? So if A is bigger than B, then do certain things. Otherwise, don't do those kind of things. So this if condition is really, really powerful and is available in all programming languages. In here, for example, let's see if A is an input, B is an input. Writing an if condition, that's if is a keyword. That's a comparison that we have done earlier as well. And then the syntax required a colon in front of that. So if this condition is true, if this comparison results true, remember the comparisons, they return Boolean values. If this comparison, whatever the result of this operation is, if that is true, then you go into this block. And whatever the statement inside is, do that. For example, print B is greater than A. Now my question is that done? Are we done with the task? The task was to print the bigger number. If B is greater than A, then B will be printed. Then, or we might have printed, for example, we might have printed, rather than writing this, we might have printed, let's say, just print B, because B is bigger. If B is not bigger than A, what we will do then? So yeah. If B is bigger than A, then B will be printed. Yes, because then you will be inside here. If B is not bigger than A, if this condition is false, we will do what then? So that's a question. So right now I'm just coding this in Jupyter Notebook, and then we will see how can we deal with that if B is not bigger than A kind of condition. So let's first see the blessings of if condition in Jupyter Notebook. Yeah. So let's say A is an integer. Let's say you're expecting an integer input, let's say, and then you write if, well, let's say B is again an integer input, maybe, and let's say if A is greater than B, then print A. That's it. That's your program. Remember this indentation. I have not written this print here. This is the indentation that defines the block of A. Let's say if I want to print A, then I want to print, let's say, I am still inside if condition. And so whatever that starts from this, whatever that starts from this alignment, if I write something here, let's say x is equal to 5, all that block is called the body of the if condition, if it starts from this alignment. If, however, I type a statement, but I type that statement in that kind of alignment, the alignment like this is no longer inside the if condition. So for example, here I type I am outside the if condition. So the purpose of writing these multiple lines is just the if condition does not require to contain only one line of code. It can contain a whole block of code, multiple lines of codes. So this is no longer inside the if condition. So now we will take input A, input B, whatever the numbers will be. If the value in A will be larger than B, then this will be printed and this will be printed. Once these two are printed, then this has to be printed regardless of the values of A and B, because this last print statement, it does not depend upon the values of A and B. The if condition has no impact on that. That is just a sequence of statements. The if condition, the statement inside the if are just these two. For example, if A is not bigger than B, then neither this will execute nor this will execute, but this will still execute because this has nothing to do with if condition. So let's run this code and see how it works. So let's say the value of A. See the power of descriptions. If we could have written a description, then the description could have appeared here. But let's say this is the value of A. Let's say 12. The value of B. Let's say 10. In this particular case, because the value of B is 10, the value of A is 12. 12 is bigger than B. If this condition is true, this statement becomes true. Whenever this condition becomes true, you are inside the if condition. Now this print executes and you get 12. This print executes and you get I am still inside the if condition, and this has to execute no matter what the values of A and B are. So now let me rerun this and give other values of A and B. Let's say the value of A is 10 and the value of B is, let's say, 45. Now this condition becomes false because 10 is greater than 45. This is not true, this is false. So whenever this condition is false, you never land inside the if condition and you go out from the if condition. So these are the statements that are inside the if condition. They cannot execute because you never visit them. They can only be executed if the if condition becomes true. So then once you're out the if condition, that's the statement that is going to be executed anyways. So yeah, so that's the flavor of if condition or decision making. And this is the comparison operator that returns a Boolean value. You may have different kind of comparisons here or combination of comparisons here, no problem, depending upon your logic. But the question is, are we done? We are going to print only the bigger number. We have printed the one that is, if A is bigger, we have printed that. What if B is bigger? We have not solved the task yet. This is the task, we have not solved the task yet. So how to do it? Okay, so yeah, it looks like complicated. How to print only that number that is bigger? So if B is bigger than A, then we will print B. Maybe we should apply another if condition. If B is bigger than A, then print B. If A is bigger than B, then print A. Maybe. Yeah, why not? So for example, let's go to Jupyter Notebook and write the following. Let me write a whole new program here. A equals int input. Okay, let's do not have a message. Int input, and then if A is bigger than B, then print A. Okay. However, if B is bigger than A, then print B. I guess we are done. If this condition becomes true, then we are here. And we know if this condition becomes true, then this condition cannot become true, because it cannot happen that A is bigger than B as well as B is bigger than A. This cannot happen. So whatever the bigger number will be, that will be executed. Further, you can see I have this if condition and this if condition. They are aligned in a way that this if condition is not, the second if condition is not inside the body of the first if condition. We will see such cases when this is required, but right now I guess we are done. If A is bigger than B, then print A. If B is bigger than A, then print B. And only one of these if conditions will become true, because A is bigger than B, B is bigger than A. These two statements cannot be true at the same time. So let's see. So A is 10, B is 45. So the answer is 45. Wow, because 45 is bigger. So let's run it again. So A is, let's say, 22, B is, let's say, 4. And the result is 22 because 22 is bigger. I guess we are done with the task. We have used this if condition twice to achieve the task, to print the number that is bigger. And both the numbers, we took both the numbers from the keyboard. Yeah, I end this video here, and in the next video, I will tell you more features of this if condition, particularly the else statement. What we have done recently with another if could be achieved through an else statement that is more powerful, more readable. So in the next video, I will talk about else statement, which is a part of if. So hope to see you in the next video. Okay, in the last video we saw if condition, and we actually had an example in which we wanted to know, we wanted to just print the greater number. So we input a number A, we input a number B, and if B is greater than A, we printed B is greater than A. Then we applied another if condition to check if A is greater than B, then print A. The else clause or the else part of if is as the name suggests, if this condition is true, if this condition is true, this particular condition is true, then go there. If this is not true, which means else, if this is true, then go there, else go there. So if this is true, then you land here. If this is false, then you land in else part for sure. And this else is, if B is greater than A, if that condition is true, then you print this thing. Otherwise, A might be greater than B or A might be equal to B. Either way, you land in else part. So this if and else, they both have this alignment, but then the block of else started from this particular alignment. Maybe you have more statements here. The alignment of this if block started from here, and you may have more statements here. So let's go to Jupyter Notebook and see the else running. So let's say A equals int input, and B is B is int input, and we say okay, if A is greater than B, then print A, else print B, else print B. Now B will be printed even if it is equal to A or if it is greater than A. Either way, B will be printed. So let's just see, let's just run this and see what happens. So shift enter, so input a number. So A is, let's say 10 and B is, let's say 12. So what do you think? When I will press enter, what will be printed? B or A? B. Yeah, B is printed. That's what B is printed. Now, if I run this again and A is 10 and B is 10, still the 10 will be printed. So let's modify. Let's just say that print if part. So that means we landed in if part. Otherwise, we landed in else part. So just to be more elaborative, let's say so 10 and 10, and we landed in else part. And the reason is if A is greater than B, so 10 is greater than B, 10 is greater than 10, false. So you go to else, and the else block, the whole block just executed. So that's what else is. It's really very nice to have an else there. If this is false, whatever that condition is, if that is false, then you land in else. So yeah, that's else part simply. Now okay, so we have this if else structure. We can have one more power with this if. What if we want if B is greater than A, then you print B. Else if A is equal to B, then you print they are equal. And if this is false and this condition is false, if both these conditions are false, then you go to else part. So basically if, else if, else if, else if, else. So you can have really deep structure. For example, in this particular example, if B is larger than A, then you land in this part. Else if, this if is just short form of else. Else means B is not greater than A. Else, you can have another check. Else if A is equal to B, then do what? If we can have one more check, we can have one more check, we can have several checks, and then else. Else will only execute if all the if conditions or else if parts on top, their conditions, they are false, and only then else will be execute. So let's see these else if running on Jupyter Notebook. Okay, so let's say A is int. So rather than taking inputs, let's say A is 1, B is, let's say, 5. Let's say we have taken these inputs, A is 1, B is 5. If A is equal to B, then do what? Print equal if, which means else if. Now because this is if, you have to write a condition here which will be either true or false. If A is larger than B, then do what? Then print, let's say, A, and else, let's say, you print B. Okay, so that's it. And this statement, print, is not in if condition, not in if. This is outside complete. This is complete if condition with all its else and else if parts, and this is no longer inside. So let's run this. What do you think? What will be the result? If A is 1, B is 5, then else part is going to be run, because A is not equal to B. A is equal to B, that's false. A is larger than B, that is also false. So you will land in else part, and B will be printed, and then a statement will be printed which is not in if. So yeah, so B is printed and not in if. If B is 10, then what will happen? A equals to B, that is false, so you will not land here. Else if A is larger than B, true, you will land here. Because you land here, else will not execute. So A will be printed and then not in if. If A is 10 and B is also 10, let's say, then you have equal. Yeah, so that's else if. Okay, so that's about if, else if, or short form is LF, else structure. In the next video, we will be talking more about this if, else structure in a bit more detail, and we will also be giving you a short form of this kind of else if, else if structure. So hope to see you in the next video. Okay, one way of writing this if, else kind of structure, there is a short form as well, which is written down here in this green color, for example. This is kind of a same code that we saw in the last video, but that's the short form. Let's say A equals 9 and B equals 10, then print A if A is larger than B, else print this particular thing if A is equal to B, else print that. This is exactly the same kind of structure. For example, print A if A is larger than B. So you just read that if A is larger than B, then print A. Else if A is equal to B, then print equal. Else print that. So that is kind of a short form of writing this if, else kind of structure. But I will recommend to use, I mean, the structure in this particular horizontal form rather than writing that in this particular way, because this kind of structure, that horizontal kind of structure, is much more readable, much more manageable, and this structure might be confusing sometime for some kind of readers, or and also if this structure goes on and on and on, which we will see in an example today. Writing very deep and lengthy structures in short form is not very feasible. So but this feature is there if you like to write if, else kind of structure in this way. This is available in Python. Okay, let's get a good grip on this if, else structure on Jupyter Notebook. Let's move on to Jupyter Notebook to see an example, just an example. So let's say the example is user will input a number. Let's say int input, let's say, and enter marks. Let's say enter marks for a particular subject. Let's say user will enter some marks, and our goal is if the marks are larger than 85, then we will print A grade. If the marks are larger than 80 but so if the marks are larger or equal to 85, then we will print A grade. Else if marks are larger or equal to 80 but smaller than 85, then we will print A minus grade. And if marks are larger or equal to 75 but smaller than 80, we will print for example B grade, for example B grade, and so on. And let's print this whole nested structure. That let's make this if kind of structure a little lengthy. Let's get comfortable with it. So if A is larger than or equal to 85, to enhance readability, it is good to include a space after the variable and space, but don't actually write the space inside that, because larger and equal to, they combine without space is an operator. So if A is larger than 85, then print, let's say, A grade. Grade. L if A is larger or equal to 80 and A is smaller than 85. So let me write this in a more readable form. Else if A is smaller than 85 and A is larger or equal to 80, then we should do what? It is sometimes good to include these kind of parentheses. Sometimes it is good just to make these things more readable, that this is one block, this is one boolean, this is one boolean, this is one decision, this is one decision. Although not writing the parentheses is also okay, but writing the parentheses make code a little more readable. So for example, if a is smaller than 85 and a is larger than 80, if that is true, so remember, and is true only when the left side is true and right side both are true, then this whole condition becomes true. And I promised you that I will show you the power of comparisons and actually combining the Boolean variables using ands and ors and stuff like so. So here you're seeing the one. In that case, let's say print, let's say a minus grade, and elif if a is smaller than, if a is smaller than 80 and a is bigger or equal to 75. If that's the case, then what should we do? Let me omit the parentheses just to show that whether writing parentheses or not writing parentheses is perfectly okay. I just recommend to write parentheses so the code becomes much more readable than otherwise. Okay, then we have print, let's say B grade, and let's say one more elif if a is smaller than 75 and a is larger or equal to, let's say 70, then print B minus grade, let's say, and let's just finish this. Let's else print below average, for example. Let's say that's our code. So we will enter numbers. If the number is greater than 85, then A grade. When this condition becomes true, then this print will execute and we will out of the structure right there. If this condition is false, then this condition will be checked. If this condition becomes true, then this print will execute and we will be out of the structure. If this is false and this is false, then this will be checked. If this is true, then we print B grade and we are out. But if this is false, then this will be checked. And if this is true, then we will print B minus grade and we will be out. If this is also false, then we will dive into else part and we will say, okay, below average. So let's see, for example, let's say the marks are 82. So A minus grade, that makes sense, A minus grade, because the marks are smaller than 85 and larger or equal to 80, so A minus grade. Yeah, let's run this again, and we have, let's say, marks, let's say 64, below average. Okay, great. So you see this if, elif, else, this can go as long as you want depending upon your logic. So great, and further you can combine several comparisons, several booleans together with ands and ors and nots, whatever you like to do. Let me give you one more beautiful thing. Let's create an else without writing an else. Let's just write elif and implement else, completely else. So we are not going to write else explicitly, but we are going to write a program that actually simulates else. So let's see, if a equals, let's say 3. If a is larger than 10, then print, let's say, larger than 10. Now we are not going to write else, but we are going to achieve the else part. If not a is greater than 10, you see, then print else part. You see that? I mean, that's beautiful. If this condition is true, then go there. If this condition is false, then not of false is true, then you land here. And you need not to write an else part if you want. Just I have implemented else part using elif. So you see that? So else part. So we are in else part. If a is, let's say, 13, then we will print, okay, greater than 10. Well, just for fun. Just for fun. Okay. Okay, great. So we saw if condition, its shorthand, and else if structure in a bit more lengthy way. So in the next video, we will see if condition inside or in the body of another if condition, which is called a nested if. So hope to see you in the next video. In the last video, we saw if else if structure. In this particular video, we will see nested if, or simply called if inside the body of another if. So let's take an example to understand what nested if condition is. Simply we can understand if condition inside another if condition, that's all. Rest of the story is the same. The way if works, it works even if it is inside the body of another if, or anywhere actually. So let's say we have input a number and then we check if x is larger than 10, then you move inside the if condition, if that is true. If that is false, then you are here, whatever you write here, it will work from here. But let's say x is greater than 10, then you print your number is greater than 10, your number is above 10, let's say you print that. Now, after this statement, you move to this statement and you just make another check. If x is larger than 20. Now you see this if condition, this particular statement is inside this particular if condition. If this condition becomes true, only then you dive in. Otherwise you're not. So here you are checking if x is larger than 10, then you move inside, and inside you are making more checks. So for example, if x is larger than 10, then you print or do some stuff here, and then you apply further more checks, more granularity, more whatever your logic is. So let's say here you are checking if x is larger than 20. Now, if this condition is true, then you move here, else. Now this else is of this if. If x is not larger than 20, then you move to this else part, and you're here. So, and we can have another if inside this particular if, or an if inside this else part, and so on. So if inside an if is called nested if, and we can have, deep structures, for example, if, then something, then if, then something, then if. So maybe we can have a very lengthy structure, if nested if structure, depending upon the logic. So let's get ourselves comfortable as always by writing the code on Jupyter Notebook, because that makes much more sense when we see things running on the notebook. So let's say a is, let's say again int, let's say we take some number, and if a is larger than 10, then we say okay, print larger than 10, and do more stuff, print, let's say inside the top if condition. Okay, then maybe we have another check. If a is larger than 20, then say print greater than 20. Yeah, greater than 20. And you can print now, print inside the nested if. Okay. Else print smaller or equal to 20, and then print, for example, inside the else part of nested if. That's it. And you can print here, print outside all ifs. Fine. So that's it. That's a structure. So let's see. Let's give an input which is larger than. By the way, if input is not larger than 10, this if condition is false, then you directly dive to this print statement, and all this structure is not going to be executed. This complete thing is called the body of this if condition. And the body will only execute if the condition becomes true, whether that condition is just a single condition or you have a combination of a lot of comparisons and a lot of booleans, whatever. If this condition becomes true, whatever that condition takes form of, then and only then you dive into this part. And when you are in this part, then that's a whole new universe. Then you are on its own in the new part. In the new part, for example, if this condition becomes true, then you are in this part. That's the body of this particular if condition, and that's the body of the else part. See, the body of the top if condition has this kind of alignment. All the statements that are in the body of if condition, they start in the same alignment, and all the conditions, all the statements that are in the body of this particular if condition, they have their own alignment. And this indentation is necessary just to define, for example, which statement is in what kind of block. For example, if I just press a tab, then another tab, then this print statement is in this else part. And this is the indentation that is defining the placement of this print. If, for example, I press, I align this with this, this particular structure here, then this print statement is inside this if condition. This is the indentation that is defining the placement of different statements. And if the print starts from here, then it is completely outside of all if conditions. It is like this way. So let's run this code and see what happens. Let's say we print, let's say we just write a equals, let's say 12. So what do you think? What should be printed? If a is 12, then first of all, this condition is true. So greater than 10 will be printed inside the top if, that will be printed. Then this check will be executed and this condition will become false because 12 is not larger than 20. Then you will go to the else part, and less or equal to 20, this number, this string will be printed, and then inside the else part of nested if, that will be printed. And then you will be out of all if condition, then outside of all ifs, that will be printed. So let's see whether whatever we have said is correct or not. So yes, greater than 10 inside the top if, less or equal to 20 inside the else part of the nested if, outside all ifs. Yeah, so that's what the nested if is. And by the way, you can have, for example, more if conditions inside the nested ifs. For example, you can have one more condition here. If a is larger than 30, for example, then do what? Then print it is larger than 30 as well, and further print, maybe not necessarily that you always write print statements. You can do any interesting stuff inside inside the nested if of nested if. Fine. And then you can write the else part of this particular if condition here if you want to, or whatever. I mean, you can have as hilarious structure as you want, but that completely depends upon the logic. Or you may have an if condition inside that else part here, for example, You can write an if condition here, if whatever, that is also perfectly fine. So if a is larger than 20, then you print this. If a is larger than 30, then this, for example. And let me write the else part here, else print less or equal to 30, and we can print inside the nested, inside the else part of nested if of nested if. Okay, so wow, you see that program? Let me just scale it down so that you can see that completely. See that program? I mean, yeah, it makes perfectly sense to me. For example, you take an input. If that is larger than 10, then you're here. If it is larger than 20, then you are here. If it is not larger than 20, then you're here. Okay, so let's say it is larger than 20. If it is larger than 20, then you're here. Further, if it is larger than 30, then you're here. Otherwise, you're here. And by the way, if a is not larger than 10, then you're directly here. Wow. So let's run this code. Let me just scale it down so that you can see it more. You can see more text, let's say. So let's run this. No errors, great. So let's say the number is, let's say 25. So what do you expect the result? So the number is 25 is greater than 10 inside the top if. It is greater than 20 inside the nested if. It is smaller than or equal to 30. So inside the else part of nested if, and then outside all the if conditions. Great. Yeah. You enjoyed that? I enjoyed that. Great. Okay, so that's about the nested if. One more thing that I have already told you, but just let me tell you the power of indentation. You are here, for example, in this particular if condition. That's the if condition, and that's the nested if. And that's the else part of this if. If you move this else part in the indentation or the alignment with this if, then this is else part of this if, and this is not the else part of this if. So remember the power of indentation. This is the indentation that defines which part belongs to what kind of block or structure in Python. In other languages, sometimes, for example, in C++, they normally use to write these curly brackets to define a block, and their indentation doesn't really matter. But in Python, this is the indentation that actually defines each and everything. So for example, this is a crucial example. If this else just moves backwards and aligned with this if, you get this else with this if. These are two if and else structures. This is still nested if without an else part. And if this else move somewhere in between, I mean, if this is not aligned with this if, this is not aligned with this if, you get a syntax error because that is not a proper indentation. So focus on indentation. That is really, really important. Yeah. So although I've told you that the indentation has already told you, but I just found to make a slide over this else part because that's important. Sometimes you may get confused whether this else belongs to this if or that if. Well, the indentation defines this else belong to what. Okay, I end this control flow indentation here. So from next video, we are jumping toward loops. But before loops, I just want to write a lengthy program in if, else if, their combinations. I just want to write a Jupyter program for you to get comfortable with if, nested if, the conditions that are ands and ors and nots or stuff like so. So in the next video, we will be practicing more on Jupyter for if conditions, and then from the next video, we will be jumping toward loops, the very, very powerful structure. Okay, hope to see you in the next video. Okay, so let's just practice this if condition a little bit more. In this particular video, I'm we are going to achieve a particular task. So let's design some task here. By the way, this is comment. Comment is it starts from a hash symbol, and that's a statement that will never be executed. This just describes your code, for example. So it is not there, but it is there as a text, but not as a code file. Like hash sometimes represents comment or description with a single line. If your comment goes on multiple lines, it is good to write a multi-line comment. So that's a single line comment, for example. Single line comment. The multi-line comments, they start with 3 quotes and then end with 3 quotes. So whatever you write inside in these in this particular block, that's a multi-line comment. So let's describe our problem in this multi-line comments, because that's the problem in form of text, and then we will be solving that problem using the code. So that's just description of the problem. Let's say user will enter a floating point number, let's say 238.915, let's say. Okay, your task is to, so let's just more readable. Your task is to find out the integer portion before the decimal, before the point, let's say before the point. In this case it is 238, and then check whether if that integer portion is an even number or not. So just print yes or no. So print even if it is even number, otherwise print odd. So that's the problem statement. That's the problem that we are going to solve. And this is just comment. Now we are outside the comment. That's a multi-line comment. Yeah. So how to solve that problem? How to solve that problem? So let's start solving this problem. I'm going to spend some time on this program just to get comfortable with the if conditions. Let's say that number is x is input. Let me convert that input, enter a real number, let's say. Okay, we are just assuming that the user will enter a real number. It's a real number. Real number might be, 238.0, that's a real number, or 238 itself, that's also a real number. That's okay. But we are not assuming that the user will enter, let's say, some characters like ABC or stuff like so. Just assuming that. Okay. Now, assume that x contains a real number. It may be an integer by default. Maybe user just enters 10, and that's it. So it may be already an integer. Then we have to check whether that 10 is even or not. Or the user may enter 11.7, or the user may enter minus 34.7, or the user may enter just 0, or user may enter just 0.35. There are a lot of possibilities that the user come up with. This x can contain any kind of number, and we have to check according to. So how can we move? Let us just see whether that number, let us just extract the decimal portion, the portion before point. Let us just extract that. How can we extract that? There are two conditions. First of all, let's see, if x is positive, then do what? Else do what? So let's write this structure first. If x is positive, then what we have to do, and if x is negative, then what we have to do. So if x is positive, then what we do, we just so what should we do? I'm just stuck here. How can we extract the decimal portion, the portion without this particular thing? How can we extract that? That's tricky. That's kind of tricky. Yeah. So any ideas? I guess this the structure I'm using. Let us just first think that x is positive. Just make our life easier, and then if x is positive, it's a positive number. How can we extract this portion out? Just the number that is below, that is before the decimal point. What should we do? Can we apply a round function? Will that help? X, will that help? Helps? Yes or no? Round function. So let's say y contains the rounded value of x. Then so what? Then how can we extract the decimal portion, the integer portion? Or maybe there is a function that actually round downs. Let me check whether there is a function float or not. No, float is not a function, I guess. So let's say round x. Okay, now y contains the rounded value of whatever the x is. We are now assuming that x is positive. Okay, then what? Now if y is larger than x, that means we moved up. Okay, we moved up, the round goes up. In that case, what we do is we just subtract so we just subtract the integer portion. So the integer portion, let's say that's our variable name. Then the integer portion is simply y minus 1. Is that correct? Is that correct? If y is larger than x, then integer portion is simply y minus 1. For example, just think about it. If when for example, if the value was 29.6 and the rounded value will become 30, so 30 minus 1 will be 29. That is what we are interested in. So yeah. So otherwise, if, for example, else if y is not larger than x, then y itself is an integer portion. Y itself is an integer portion. Is that correct? I mean, is that making sense to you? That if, for example, if x is larger than, if the rounded value of x is larger than x itself, then we just subtract 1 and we get the portion. Otherwise, the rounded value itself is the portion. Let's just run this code for now and check whether whatever we have done so far is correct or not. So after that, just print, let's say, the integer portion. Let's just print that. Okay, so enter a number. Let's say the number is let's say 25.367, let's say. Obviously the integer portion here is 25. So let's see our program returns 25 or not. Oh, the result is 25 magically. Oh my god, we found 25. Let's run it again. Just to see. Okay, let's run this again, and this time let's give it to 45.8. Okay, the integer portion is 45. But when we will round, we will get 46, and 46 minus 1, we will dive into this particular if condition. Let's see. Oh, the result is 45. We are still moving very well. Great. That's great. So, okay, let's play with it. Let's give 0.2. The result should be 0. It is 0, right? Let's run it again and give it, let's say 4. That's it. The result should be 4 now. It is 4. Great. So we are working very well. We have extracted the integer portion as long as the number was positive. Okay, great. What if the number will be negative? Let's say that was true. If that was true, so that whole logic works if x was positive. So if x is positive, then whole this logic just works. Okay, then else what should we do? If x is positive, then this logic works. If x is not positive, then what will happen? Then how can we find out the integer portion? Because first we have to find out the integer portion, and then we have to find out whether that integer portion is even or not. Finding out whether that integer portion is even or not might be simpler, but first we have to find out the integer portion. So for example, let's check the behavior of round function on negative numbers. Let's say round minus 9.3. So the result is minus 9. Okay. If we say, okay, round minus 9.6, the result will be minus 10. So it looks like the same as working in the positive numbers. So round function is actually working roughly the same way it should work in the positive numbers. Okay, so what should we do here? Any idea? Maybe we first convert by the way, yeah, maybe we first convert the number, let's say y equals round x again like before, but then what? So maybe this rounding helps the same way. Maybe the rounding helps the same way. We should extract this x out from this here, because it is going to work in the else part as well. Why to compute it? Why to write this redundant code? So y is round x, let's say. Then if y is greater than x, what should we do? If it is negative, y is greater than, then what will be the portion? It will be, the integer portion will be what? Y minus 1 or what? Y plus 1. Yes, you got the answer. That's y plus 1. Great. And else, I guess we have integer portion equals y itself, I guess. Yes, I guess that's the code. That's the code, I guess. Let's check, by the way, but I guess that's the code. By the way, this else part is same in both of these conditions. So maybe we can combine this code and write a more elegant code, but I guess this will work. Let us just print the integer portion just to check whether we are working well so far or not. So let's enter, let's say 12.3. The result is 12. Great. So it did not change our previous, I guess, our previous logic. So let's say there is minus 9.8. Now the integer portion should be minus 9. Oh, it is returning 10. Why is that? Why is that? Oh my God, this should be changed. When it is round, it may go that way. When it rounds, it actually becomes lesser than 10, because when it rounds, it goes up and it becomes lesser than. In negative world, this condition should flip. Yeah, so we are making an error here. Let's fix that. Okay, let's run this again and see. Let's say minus 93.2. Minus 93, great. So then we have, let's say, let's run it again, minus 8.9. Minus 8. I guess we are working perfectly fine. Once we have integer portion with us, we just write here at the very end, if integer portion remainder with 2, if that equals to 0, print even, otherwise else print odd. That's it. That's the whole program. Let's see, and let's see how is it running. Let's say 22.6, it's even. Let's say minus 87.3, that's odd. Great. So you see the power of if condition and how can we think in writing these programs and stuff like so. That was a lengthier video, I know, but I guess you get a very good look and feel of if conditions and thinking and building a logic and all that stuff. So in the next video, we will start loops. So that's a beautiful structure. Hope to see you in the next video. The best way to understand loops is to think about in a repetitive structure or repeating structure. Let me give you an example, and we will dive into this code in a while. The example is, let's say a user gives you a number, let's say integer number, and you want to print all the numbers till that number. Let's say you start from 1 and you keep on moving and printing all the numbers as long as you reach that number. So for example, if user enters, let's say 5, your goal is to print 1, then print 2, then print 3, then print 4, and then stops. Then stop, just stop. Or let's say if user print, if user enter, let's say 3, then you print 1, you print 2, and then you stop. This is easy. If user enters an n, we can just print, we could have written this thing, print I. Let's initialize a variable I with 1, print I, and then I equals to I plus 1, or in Python we can write this quickly as I plus equals to 1. That means in I store I plus 1. This is the short form of writing this. And then after that you just apply an if condition. For example, here you can apply an if condition and say, okay, if I is smaller than n, you keep on printing, and after printing you just increment again this, then check the if condition and keep on moving. Well, that is feasible if n is 5 or n is 3. What if n is, let's say, 50,000? I mean, you're writing all that structure again and again and again. I mean, that's a whole lot of code. Well, the loops are just a solution of this kind of structure. When you want to perform same kind of task again and again, the loop gives you the facility to do that. For example, let's just consider a while loop. This is again a condition similar like a condition in if condition. Like in if condition, you evaluate this Boolean expression. That's an expression that results a Boolean value. While this condition is true, you will stay in this block. And after executing whole block once, you check this condition again. If this condition is again true, you will dive into this block again, then check the condition, dive into the block, then check the condition, dive into the block. As long as this condition stays true, you stay in the block, you move inside the block. Once this condition is false, then you exit this while loop, then the loop terminates and you move on to the further processing. Just like in if condition, just like if conditions, if the condition becomes false, you exit that if condition and you go moved on. So in this particular case, for example, if n is 5, let's say if n is 5, user give an integer number that is 5. I is equal to 1. Now 1 is smaller than 5. The condition is true. You move inside. You print I. The value of I is 1. So that's what you print. You print 1. Then you change I. You increment I with 1. That means I equals I plus 1. So I becomes 2. Now the body of the loop finishes. That's whole body of the loop. The body of the loop can have many statements, a whole block of code. Once I becomes 2, you move on and you check, okay, 2 is smaller than 5. Yes, it is true. You move inside the block again. You print 2. Then you update I. The loop body finishes. Once the loop body finishes, you go and check the condition again, whether that condition is still true or not. It is still true. I is 3. 3 is smaller than 5. Yes, you move inside. You print 3. You update I. You check the condition. 4 is smaller than 5. Yes, you move inside. You print 4. And then you update I, and then you move on. Now 5 is smaller than 5, false. Once the condition is false, you will not dive into the body of the loop. You will exit the loop and you will print done. And that's it, done. So this loop becomes very handy in applications that have repetitive structures, and in most of the interesting programs, most of the interesting problems, these are the loops that play a very huge role. So let's go to Jupyter just to get our hands on this loop. For example, let's say x is again, let's say int or n. Let's take n. N is int input. Let me make this a little bigger, just to, let's say that input, and input is a number. Let's say n. I is your certain, let's say 1, while I is smaller than n. You may have written this parenthesis just to create the readability, just to make the readability, and otherwise, I mean, this is also okay. That's perfectly fine. As long as I is smaller than n, keep doing the following. What you do is print, for example, the square of I. Print the square of I. That's a square of I, let's say. And then you say print, for example, this is iteration number, and then you just print I. That's the iteration number I of the loop. That's the iteration number I. This is just a string. This is just a string, and that's a variable. Its value will be printed. This print function takes as many arguments as you pass. So you can write a comma here and continue whatever you want to print. That's a very flexible function. Okay, then what you do, you say, okay, I plus equals to 1. By the way, this I plus equals to 1 is the same as I equals I plus 1. You see, I have just commented here just to explain what this is doing. If I just write I equals I plus 1, that is also correct in Python, but that's kind of a shorthand. Okay, and that's it. Now again, when I de-indent, I'm outside the loop. This is print loop done, for example. So that's the code, for example. So let's run this code. Let's run this code. For example, let's say n is equal to 5. Then we have 5. So this is 1. This is the iteration number 1. Then 2 square is 4. This is the iteration number 2. Then 3 square is 9. The iteration number 3. Then 4 square is 16. This is the iteration number 4. And then the loop finishes. That's it. That's a first snapshot of the loop. We will continue from here onwards in the next video, and I will show you more and more flavors of this loop. So hold on and wait for the next video. Okay, in the previous video we saw while loop, and we saw one one program related to while loop, just printing a bunch of numbers till a particular number. Well, when you are inside the body of the loop, that's a whole new, you can write whatever you want to write. For example, you can apply an if condition inside the body and check that at each iteration a particular decision should be made or not. For example, in this particular case, I'm going to print I whenever I is an even number. So I is some number. If it is even, then print it, else pause. This pause statement, for example, is just a statement of saying that do nothing. It is just a shortcut of writing do nothing. We could have omitted the whole else part along with this pause and still the code is equivalent, but sometimes writing this pause make the code readable just. So writing this pause statement just means do nothing and just move on. If we omit else statement and we omit this parse, that's perfectly okay. So for example, let's try run this code. Let's say n is 5, I equals 1, 1 is less than 5, yes, 1 is not an even number, so go to else part. Else means pause, which means go on, and then increment I. This print statement is outside the loop. This is aligned with this while. This is not inside the body of the loop, otherwise it should have been indented inside. Now I is incremented, I becomes 2. Now move back, 2 is smaller than 5, yes. 2 remainder 2 is 0, yes, so print 2, so 2 will be printed. Because if executed, else will not execute and I will increment, because I is not inside the if condition, it is inside the body of the loop. So I incremented, I becomes 3, you go back, 3 is smaller than 5, yes, 3 remainder with 2 is 0, false, so pass. I plus 1, so I becomes 4. 4 is smaller than 5, yes, 4 remainder 2 is 0, yes, so print 4. So else will not execute. Now increment I. Once you increment I, you get, for example, I equals 5. Now 5 is smaller than 5, false, so you go out of the loop and you print done, and that's what this code is. So you can have if condition inside the loop, you can have nested if inside the loop, you can have loop inside the loop, nested loops. We will see examples of nested loops as well. I mean, that's all allowed or sometimes really required. Okay, so next there are two important statements that are there. One is break, one is continue. I want to focus these statements because they have a deep link with loops. A break statement, wherever written inside the body of the loop, tells that exit the loop immediately. Whenever this break is encountered, whenever this break executes, it exits the loop immediately and brings you outside the body of the loop. That's what it does. Break. So for example, if I becomes divisible by 17 and the remainder becomes 0, you will print a break. And then when this break statement will execute, you will exit the loop immediately, regardless of what is the value of I, what are other states, whatever. Break exits the loop. Okay, great. Now the continue. Continue statements, continue statement wherever encountered, continue brings the next iteration loaded regardless of the remaining statements in the loop. For example, when this continue will be executed, no matter how many statements are there onwards that are there in the body of the loop will not finish its iteration by going through all the remaining statements, but it will start another iteration immediately. So continue basically skips the remaining body of the loop and starts another iteration. Here I have written this true. True means while true means always run. You might be thinking always run. It's an infinite loop. Will it when we will exit the loop, because this true statement will always stay true, we're not changing this true anymore. There is no condition here. That's true. While true means always go inside the loop. But whenever this break is encountered, you are outside the loop right away. And this break exits the loop. This continue skips the remaining portion of the loop body and starts the new iteration, starts another iteration. So this continue means start another iteration immediately, skip the rest of the statements. So rest of the statements inside the loop body. Okay, so let's just practice this break and continue just in Jupyter Notebook to get a better look and feel of the loop. So let's say we have, let's say again, let's say n equals, let's say 10, or we might have taken that as an input. Let's say n is equal to 10 while true, which means keep moving. We might have taken some value here, I equals, let's say 1, while true, if I remainder with, let's say 9, if that is equal to 0, then just break the loop. Else what you do is really you increment. Else what you do is if I is not divisible by 9, then what you do is I equals I plus 1. That's true. By the way, previously we have written this way, so either way is fine, whether you write a short form or this form. So else this. Okay, and that's it. The loop finishes. That's the loop. After the loop, you just write, okay, print the loop is done. So let's see what's the output. The output is done straight away, and the reason is why it is, 1 is divisible by 9. Only then you could have break. While true, why the loop? It does not print anything. We could have printed some statements so that we know that we went inside the loop or not. Okay, so inside if. So for example, print inside else. So let's run this again. Okay, great. Inside else, inside else, inside else, inside else. The first time it go inside if, that time it breaks and it goes out and prints done. That's what this break statement does. So let's see an application of continue statement. Let's, for example, just copy and paste that code into another cell and see how this continue works. So let's say we have a loop like so. So what we say is like this: if I is 9 is not equal to 0. If this is the case, if I is not divisible by 9, what you do is you take I plus equals to 1 and then continue to the next statement. And whatever else you write here, for example, print something, print something else, whatever, that will not be printed. And once the continue will be encountered, whenever this I is whenever this I divisible by 9 is not true, if I is, then you continue. Once this I is divisible by 9, for example, then you will not dive into this if condition. Only then these two statements will be printed, because this continue will not allow anything further that should happen. And once these are printed, let's say we break our loop right there, let's say. So if, for example, for the very first time 1 is not divisible by 9, So I equals 2, so continue. These three statements will not be executed. The next loop, the next loop, the next loop. Once this if condition becomes false, this continue will not operate, and then we print this statement. Then only then we will print this statement, and only then we will break and we'll exit the loop and print the done. So let's print here, print inside if. So let's run this code. Let's run this code and see what happens. That's the code. Maybe I should just, yeah, that's a better font. Let's run this code. So when the code is run inside if, inside if, inside if, you see when you are inside if, when you continue, when this is the body of the if condition, when if condition completes, it should print these two things. But continue is telling the cursor to go back to the next iteration and move on. And once this if condition becomes false, only then you get this thing printed, this thing printed. If this break was not there, you then again was going to the while loop, and you will be running an infinite loop, and then you have done. So that's what this continue and break does. So in the very next video, we will see another kind of loop. Here we saw the while loop. In the next video, we will see a for loop, very powerful and very famous kind of loop. For it does almost the same stuff as while loop. While the while loop runs based on a condition, the for loop, it runs based on counter. It's a counter loop that many times it should run, and so on. So we will see the details of for loop and the applications of for loop in the next video. Hope to see you in the next video. Okay, in this video we are going to discuss for loop, another kind of loop. In the previous video we saw while loop. Although most of the stuff, almost all of the stuff can be achievable through while loop, but sometimes it becomes handy to apply for loop. In this particular example, I'm going to populate a list. So before actually moving towards for loop, let's see very shortly what a list is. Although we are going to explore this list in much more detail when we will discuss the data structures module, but just for the sake of example, a list is a collection of different kind of elements. For example, 2, 3, 4, that's a list of 3 elements. So 2, 3, and 4. The list can contain different type values, for example 2, 3.4, and stuff like so. We can access different elements. For example, L of 0 means the very first element. The indexing, this is called the index. The index starts from 0, then index 1 is. So if we print, for example, print L of 0, the result that will be printed will be 2. Similarly, we can append more values inside a list. Append, let's say 53, and the list, after this append operation, the list will be having these values 2, 3, 4, 53. We can remove, delete, update, and do a lot of stuff. We will see lists in detail, but just for this example, just think that list is a collection of a lot of elements, and we can add, insert more elements, we can delete elements, we can change elements, and so on. Or we can just initialize the list with just an empty list and start inserting elements one by one and expanding that list. Okay, now this is an empty list, for example, and for I is just a variable. For I in this range is an iterator. Range 10 means sequentially give a number one by one starting from 0. Start from 0, give numbers one by one. For example, first time give 0, I will contain 0. Second time give 1, third time give 2, and so on. After every iteration, the range will give another number as long as the numbers, they are smaller than 10. So the last number that this range will return will be 9. So whatever this is written inside is not included, and it starts from 0. So as long as I is in this range, I is lower than 10, as long as that's the body of the loop, just like the body of the while loop. So first time I will be 0, and 0 is smaller than 10. Okay, you print I plus 1 and append the square of that in a list. Then next time this range will automatically return the next number into I. Now next time I will contain a 1. Next time I will contain 2. Next time I will contain 3, 4, 5, 6, 7, 8, and 9. Once the value of I becomes 9, that's the last iteration of this body of the loop. And after that the loop finishes. So let's just try run this. Very first time I will be 0. When the loop enters its body very first time, I will be 0 and 1 will be printed because we are printing I plus 1. At that time the list and the empty list will be having one number, which is 0 square. So list will be having just one number, 0, because 0 square is 0. Next time I will be 1 and we will print 2 and the list will contain 1 square, which is 1. Next time I will be 3, I will be 2, we will print 3 and we will be having a square of 2, which is 4, and so on till 10 here. When the I will be 9, we will print 10, and in this list we will be having 9 square, which is 81, I guess. And after that the loop finishes and we will be out of this loop. Okay, let's see this. Let's see example of this in Jupyter, just to get more comfortable with the list as well as the for loop. So let's see. Let's say we have an empty list. Let's say an empty list. Just consider a list like this. L is just a variable. You can write another variable name. That's a variable name L. Okay. So for I in range, in is a keyword, range is a function, in is a keyword. I in range, for example, let's say 10. What you do is you print I plus 1 or whatever you want to do. That's the body of the loop. And L dot append, that's a function of the lists. We will see that in detail in the data structure sessions. Okay, and that's it. The loop finishes. When you finish the loop, just print the whole list. So let's say print the list, and you can see the result 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and that's these are the values in the list as I mentioned earlier. All these are the values. By the way, this range function actually, what if we want I to jump more than just 1? For example, we want I to start from 0, it reaches 10, and let's say we want the jumps to be taken as 2 rather than 1 and 1. So the very first time, so that's the start location, that's the end location, which is not included. Start location is included, end location is not included, and that's the step size. So very first time I will be 1, you move inside, then a jump of 2 will be taken. The next time I will be, so very first time the I will be 0, then you move inside, then the jump of 2, then you move inside, then a jump of 2, then you move inside. As long as you stay smaller than 10, you will move inside the loop, body of the loop. So let's see what now printed. Let's print just I rather than I plus 1. Oh, there's an error. What's the error? 0. Oh, the range function does not have colons. It has actually commas. Sorry, my mistake. I was just a MATLAB user once, so MATLAB actually has these colon things, so I was just confusing MATLAB notation with this. Okay, great. So so first time I was 0, next time a jump of 2, I becomes 2, next time a jump of 2, I becomes 4, then I becomes 6, then I becomes 8, and next time I becomes 10, but 10 is not included, so you're out of the loop, and that's the squares that you got. It is not necessary that you always start from 0. You can start from 1, and you can take a jump, for example, a jump of 3, and it's not necessary that you just reach 10. You can reach, for example, 20. It's up to you. It's completely your choice. And in that case, you have this kind of iterations. So this range function really is helpful for iterating over a loop body or a structure. Okay, great. So that was introduction of for loop, and we have iterated here on a list. We just have actually populated a list using for loop. Okay, in the next video we will see more details of this for loop and more fun stuff. Okay, hope to see you in the next video. Last time we saw a for loop in the last video, and magically this else has something to do with for loop in Python. Well, this else clause makes sense for if, but in for loop it hardly makes sense. But let me try to make sense of else clause for loop. There is an else part of for loop as well in Python, not in other languages. I don't know any other language that has this else part. Maybe there is some, but I don't know. So this else part in Python, particularly in for loop, this else part or else block will only execute if for completes its iterations. For example, this is a set. A set like a list is a collection. List is defined by square brackets. Set is defined by curly brackets. The set is just similar like the set in mathematics. We will see the set, lists, tuples, dictionaries, and many of these data structures in detail in data structures portion, but just I have introduced this. Just consider this set has 3 elements: apple, 4.9, and cherry. Apple is one object or one data, 4.9 is one data, which is a floating point data, and cherry is one data, which is a string data. Okay, so this S has 3 elements, 3 different elements. So now for X in this set, as long as X is in the set, the very first time the X will be apple, so it will print apple. Next time X will contain a 4.9 as long as, so iterate over this set. As long as X is inside the set, pick elements one by one and just print them all. Okay, we expect that when X is apple, when the very first time X will be apple, it will print apple. Next time X will be 4.9, it will print 4.9. Next time X will be cherry, it will print cherry, and the loop ends because there is no item in set to iterate over. Because the loop finishes its complete iteration, there are expected 3 iterations and the loop finishes those. Now the else part will execute and you will say, okay, loop completes its iterations. Well, you will be wondering in what case the else will not execute. If you apply any break statement inside the loop body, which means you forcefully remove some of the iterations that were going to be executed, but the loop did not complete its iterations, then the else part will not run. So let's see an example in Jupyter to get a good grip on this else. Okay, let's define a set. S. S is a variable name. You can have any variable name. Let's say apple, or let's say 4.9, I guess. And then we was having, let's say cherry. If these spellings are correct, I guess cherry. Okay. Then for X in S, as long as X is in S, print X. Fine. Else. Print when you finish the loop terminates with success, or all iterations, it completed all its iterations. And this is a statement that is completely outside the loop. Outside the loop. So let's run this. So you can see apple, 4.9, cherry, loop terminates with success, outside the loop. Okay, now you might be thinking in what case this else will not execute. Okay, if for example as long as X is in N, if I say, okay, let's say I take a counter here, I equals 1, that's a counter, let's say, and every time I just increment I plus equals 1, and then I check if I is equal to 3. If I is equal to 3, then just break, let's say, else, just for readability, else pass. Now this else is else of this for, and this else is else of this if. And this pause statement is just a statement for doing nothing. Now what you do when I is equal to 1, you print this. I plus equals I becomes 2. 2 is equal to 3, false. So you pause, you move on. Next time x will print 4.9, I will become 3, and 3 is equal to 3, that's correct. The break will execute, which means the loop should have one more iteration, but the break just disrupt that one more iteration that should be there. Because the loop could not complete its iteration due to this certain condition, this else part of the loop will not execute, and you will go directly outside this loop. So let's run this code and see the result. So you can see this, Apple 4.9 outside the loop. I would recommend also this else is there for loop, but I would recommend to avoid using else in the beginning. I mean, you may be confusing this else. By the way, there is a mistake here. This else should be ended with a colon here. Okay, so I would recommend to not use else clause for a for loop in the beginning until you really need it, because you may confuse this else with the else of if condition, and you may think something else and the program behave in a different way. So either way, if you want to use else for a for loop is there in Python. Okay, just one more example of for loop, and here we use dictionary. I'm introducing some data structures here just for fun. We will see these data structures in detail later on. So dictionary, that's a key value pair. It is like a set, but one item consists of two numbers. That's called a key, and that is called a value. That's a key and that's a value. Like a dictionary, we have key and values. So now as long as x is in x, x represents to key, and d is our dictionary, and d of x represents to whatever value that x points to. For example, apple is a key that points to 44. Cherry is a key that points to game. For example, if I write d apples, apple, the result will be 44. Similarly, d of cherry, the result will be game. Okay, so let's iterate over this dictionary using this for loop. All am I showing you that this for loop is very, very handy of iterating over different data structures and a lot of data and stuff. Whereas while loop is more handy in checking the conditions and stuff. Although you can do all the stuff using while loop, you can all the stuff using for loop, but one is better over the other in certain situations. So let's just run this for a dictionary. Let's say I have a dictionary D. It's defined like a set. Let's say my key is A and my value is 10. Let's say my key is B and value is minus 19. And let's say my key is C and my value is, let's say, ABC. Let's say that's my dictionary. So for x in D, print the key as well as the value of that key. So now you can see the key is A, the value is 10, the key is B, the value is minus 19, the key is C, the value is ABC. So this for loop is really, really handy in iterating over a lot of data structures and stuff, although it has other applications as well, but this is handy. Okay, great. So that's about loops, for loops and while loops. These are two kinds of loops in important loop. These are two important kind of loops in there in Python. In the next video, I will directly go to Jupyter Notebook, and we will be practicing for this for loops or while loops. We will be practicing the loops. We will be doing actually examples of nested loops. We will be actually solving a problem like we did in the if conditions. We solved a problem previously. We wrote a code for it. Here we will also write a code, and we will get a good grip on the loops. So hope to see you in the next video. We will solve a problem in Jupyter Notebook directly. Okay, hope to see you in the next video. Okay, welcome back. In this particular video, we are going to practice for loops, or basically loops. So let's have a problem statement first. What problem we are going to solve? Let's have comments. And the problem we are going to solve is, let's define given a list of numbers, for example, i.e. let's say 1 2 4 minus 5 8 7 9 3 2, like this. Make another list that contains all the items in sorted order from minimum to maximum, i.e. your result will be another list, like in this particular case we will be having -5, which is smallest, then we will be having 1, then we'll be having 2, then we'll be having 2, then we'll be having 2, then we'll be having 3. So all the items, but in minimum to maximum sorted order. Then we'll be having, I guess, 4, then we'll be having 7, and then we'll be having 9. So that should be your output in another list. So assume this list is available to you, or any list is available to you. Assume this list is available to you. So how to solve that problem? Let's start. Okay, let's assume that the list is available. Let's say this is the list we are going to sort. Let's say this is available. Okay. Okay. So what should be the logic? What should be the logic? How can we solve that problem? This is an easy looking problem, but it is not so easy. Let us first write let us just simplify this problem to just finding out a minimum from the list. Let's say we are given a list and we just want to find out minimum number, one minimum from the list. So how can we move that? So let's say m is some number. So m is the very first value of the list. M is our variable, let's say. That's the first value. And what we do is for I in L, as long as I is in L, if I is smaller than m, then if I is smaller than m, then m should contain I, otherwise do nothing. That's it. So at the end, print this m. Print this m at the end. So print the minimum number. Let's say m. Great. So so that's the basically so yeah, that's the that's how we will find out just the minimum value. So let's run this code, and the minimum is -5 available to us. What if we want to store the minimum value as well as the position of that value? For example, we not only want to just find out what is the minimum number, we also want to find out at what index. For example, here 0, 1, 2, and 3. At the third index, we found the minimum. What if we are interested in the index as well? So let's say for the very beginning, the index is 0. And then what we do is we moved on, and we say, okay, we maintain a counter. Let's say a counter is c equals 0, for example, right now, and c just plus equals to 1. That's a counter. And then this idx is just that c, whatever that c is. So whatever that index is, when we find this c, that index is also there. So let's print the index as well as the minimum value. So okay, so at the position 3, at the index 3, we found the minimum value. Okay, now we have written kind of a code block that helps us finding out the minimum value. How can we actually so the basic logic is you find the minimum value and swap that value with the very first value. Okay, great. And then move the loop. Next time, find out the minimum value from the remaining list and swap that minimum value with the second value. Next time, you find the minimum value as long as the position and swap that with the third value and so on. So do that stuff and just rearrange the same list using this. But how can, so that's the logic. Find out the minimum value, swap it with the first value, and then start from 2 till end. Start from the remaining values, find the minimum, swap it with the first value of the remaining list. Then reduce the list step by step, and you will be having a sorted order. But how to start with? How to find out like this? How to do that? So any idea? I mean, we are going to. So for example, in this particular case, if I want to swap the list, what I will do is I will say, okay, swap with 0 at the 0. So I will contain a temporary variable. Temporary variable will contain the value of 0, list 0. So what I will do is at list 0 write the minimum value, and the minimum value, so at 0 you write the minimum value, but at this particular index from where we found the minimum value, just place the value at the very beginning. So after that operation, the minimum will be at the first position or the 0th index, and that value will be, so minimum value will be swapped with the very first value. So let's run this code and see what a list looks like after that code. So you see, for example, the minimum value is swapped by the first value, whatever the first value was. But we want to do that progressively for the rest of the list. We want to find out the minimum and swap with the first one for the rest of the list and keep on moving. How can we do that? So yeah, so let me define for. So let me first indent that a bit. Let's say control right braces, that will indent all my code. So for j in range length of the list, whatever the length of the list, let's say for j is that. So what I do is m is the jth value. The index right now is j, and the c is also the counter c is also starts from j. Okay, great. Now we want I to start with now we want this I to start from j and move onwards. Yeah. So let's say I in range, start from j and go till length of L one by one. Take the step of 1. Okay, great. So what next? Now the value will be L of I rather than simply L of I rather than simply I. In that case, you do this. Okay, and the index is just C. Okay, great. Keep on introducing this index again and again. After this loop, what you do is you pick the jth value, you swap the jth value with the minimum, and you do that, and that's it. You keep on moving, and after the outer loop finishes, if you print your list, you will be having the list sorted order. At least we hope so. So maybe there is a bug in the code, maybe there is a problem in the code, but we hope this will work. What we are doing progressively, by the way, this is a nested loop. This is a loop inside the loop, and that's and then we have an if condition inside the nested loop, loop inside the loop. Great. Let's see how it works. If there is no, oh, there is an error. length of range. Oh, we haven't write a colon there. Don't forget this colon. That's a problem. Oh, we have a sorted order. Oh my God, we have a result with us. You see the applications of this. Oh, 1 3 is missing. Where is 3? We have 2 3s. Oh, the output we have written here is wrong. There's no 2 3s. There's only 1 3. So you have sorted a list. If you remember, we have written a similar kind of code in the problem solving session very earlier, where we solved this problem using selection sort. But there we just wrote a pseudocode, and here we have a code much simpler than actually the Python code. If the problem was just sorting, there are built-in functions to do that, but I'm just telling you how these loops and if conditions and all that stuff can be used to communicate with each other, to match with each other, to actually perform a problem-solving task when given a problem. Although we will see later on in Python, most of the problem-solving tasks, I mean many more of them, there are built-in functions for those, there are available functions for those. You need not to write all that stuff, but to master any programming language, you have to go through these constructs, so that for a new problem or for a very large, complicated kind of problem, eventually you may need these kind of structures with you. So mastering these structures is really essential for problem solving and programming in general. So, okay, that's about the loops and if conditions and control flow, all of that. In the next video, I will start talking about functions. So you have seen this len, that a function. You have seen this range, that's a function. Iterator, although you have seen round function, you have seen div mode, you have seen print function. What if we want to write our own function? How can we do that? From the next video, I'm going to show you how can we write our own function. Wow, isn't that great? That's great. So hope to see you in the next video.